When you walk through a neighborhood like this, you might spot a few ants on the sidewalk and write them off as generic suburban pests. To most of us, they are either black ants or red ants, a single uniform nuisance. This chart shows the biological reality is far more extreme. We have documented 14,000 distinct species, ranging from colonies so small they live their entire lives inside a single acorn, to the African driver ant, where a single queen can reach 52 millimeters in length. To organize this diversity, researchers trace the lineage back to a primary evolutionary split. On one side are the poneroids, the ancient solitary hunters. On the other are the formicoids, the highly social ants that make up the majority of our daily encounters. As these lineages travel forward in time, they branch into dozens of subfamilies, but nearly every ant on Earth belongs to one of these 5 major branches. Understanding these 5 specific subfamilies is the only way to decode the survival strategies that allow a 14,000 species workforce to operate across the globe. We find the most primitive strategies in environments like the African savanna. Here, the Ponerinae operate in simple, ancient societies. Unlike the massive colonies of modern species, these ants function as specialized, solitary hunters. The trapjaw ant uses a mechanical lock to store energy in its mandibles. When triggered, they release in a single explosive snap to capture prey. This chart maps the Schmidt-Sting pain index, and it shows that the bullet ant possesses the highest possible ranking. Its level 4 sting delivers a neurotoxin so intense it can cause localized paralysis. Nearby, the Dorianae, or army ants, have taken a different path. They have completely abandoned permanent architecture in favor of a life of constant, blind, nomadic movement. In Africa, driver ant columns can contain millions of workers. Without sight, they rely on sheer volume and a powerful bite to overwhelm and drive away every other animal in their path. These ancient lineages prove that simple tools like stingers and mandibles remain elite survival mechanisms when applied with overwhelming force. Curious, the Formicinae branch took a different evolutionary turn, trading the primitive stinger for the acidopore, a chemical nozzle at the tip of the abdomen. This mechanism allows an ant to defend itself from a distance, firing a targeted mist of concentrated formic acid at an attacker. The Dolichoderinae utilize chemistry even more broadly. These chemical warriors secrete complex odors, not just to repel predators, but to signal social instructions, such as coordinating where the colony should dig. This coordination reaches its peak with weaver ants. Workers form chains to pull leaves together, while other ants carry larvae back and forth, using their silk as a biological glue to bond the edges into a nest. The transition from physical venom to advanced chemistry provided the foundation for some of the most complex, coordinated societies on Earth. The largest and most diverse branch is the Myrmicinae. With over 7,000 species, this group has adapted to fill nearly every ecological niche. This diagram of a desert honeypot ant shows a specialized caste of workers called repletes. Their crops expand to hold massive liquid food reserves, allowing them to hang from the nest ceiling as living storage tanks for the rest of the colony. In the tropics, turtle ants have evolved flattened, shield-like heads. These soldiers use their anatomy to physically seal off the circular entrances to their nests in tree hollows, acting as living doors. We also see the limits of evolution in rare outliers like the dracula ant, which drinks the blood-like fluids of its own larvae, or the dinosaur ant, which still lacks the different worker jobs seen in more modern species. The vast success of the Myrmicinae shows that there is no single correct way to be an ant. Every environment demands a different biological solution. By diversifying into these specialized subfamilies, ants have conquered every continent and ecosystem on the planet. They function as critical partners in human economies. In Indonesia and Malaysia, black cocoa ants protect trees from pests, allowing farmers to produce more cocoa pods. In citrus orchards, weaver ants act as biological guards, while other species consume termites and aerate the soil. The next time you spot an ant, it is worth looking closer. You are seeing a single worker from a 14,000 species scientific order, operating with millions of years of evolutionary refinement. As they protect our crops, aerate our soil, and manage forest insect populations, the health of the biosphere